Everyone, I'm going to talk about automated CV screening and evaluation AI system. And by name, I'm Mashala Desire, Precious, Makerere University, doing computer science. In my previous presentations, I had talked about the problem I'm trying to address. The one for the CVs, like the documents, like kind of like reducing the hectic work that the employers tend to face with reading the resumes, or what you guys know as CVs. Yeah, so this one, it's like to help us out because it's kind of a hectic work reading them like through and thoroughly. I also talked about, in my previous presentation, I talked about the data set I'm going to be using. But again, I'd like to pass through it briefly. I'm going to be talking about the resume data set. That's what I'm going to be using. And for it has some examples and some samples of CVs. So in our data set, there is tokenization, lemmatization, frequency distribution, and the word cloud generation. So here, this video today, I'm going to go like in details on how the data set is going to be operating and how that we are going to program our AI model. First, I'm going to talk about the exploratory data analysis. This is an approach to analyze the data using virtual techniques. It is used to discover trends, patterns, or to check assumptions with the help of statistical summary and graphical presentation, like presenting the data of in the data set using presentation, like graphic presentations. In this, we can express this, we can talk about these graphic representations like heat maps, correlation matrix, box plots, feature independence plots, outlier plots, illustration of patterns of interest, illustration of trends in time and space, bar charts, pie charts, and a word cloud. Now for this case, I'm going to be talking about the EDA for this project. For this project, since it's a CV, if you are to determine the summary that you are going to, like the graphical presentations that you are going to use, at times the type of data that you are using and the data that you have depends. Now for my project, working on a CV analysis, and I'm using text data. Yeah, it's text data, like the data type. And so I have issues with that I don't have numerical data to generate these graphic representations, like the heat maps, the box plots, the correlation matrices, the illustration of time and space, like the ones I had tried to list out. Because when I try, they don't generate anything, since they're only words and they can't generate them without the values. Because for the heat map, they are code for the correlation matrices. Yeah, but according to this project, I can try to briefly show my work or the data by presenting it in a bar chart or even in a pie chart, like as shown. I'm going to show you. Here we can see that there is a bar chart, and this bar chart is briefly talking about the count, the number of CVs or the number of people applying for these things. So the samples that we have for our model, most of it's the Java developers, and also the advocate seems to be the lowest. Yeah, but it's talking about the count, like how many CVs we are talking about here, like the resume samples we have for our model to use for training and testing. We also have a pie chart, and the pie chart is also showing the category distribution, like the different categories in which people will try to be applying for, like the ads, advocate, HR, the human resource, data science, testing, blockchain, all that. So different things. Then we come to the word cloud. Before I show the word cloud is generally like it is to illustrate, it's trying to show like, okay, for the part where we are using like the type of data that I'm using and the type of data that I use. For it helps to show like it's like a frequency distribution of words that are commonly like being seen in the resumes or in the CVs. So for it, that's how it comes out. It shows the words that are kind of like mostly used. Yeah, and for it will be helping the AI, like the AI model, at least to easily recognize these words when it's trying to screen the resume or the CVs. Then we come to the machine learning pipeline. For the machine learning pipeline, this is like we are going to talk about the practical part, like trying to implement what we have been talking about, like in the data set. This is going to include like libraries. We are going to talk about like libraries, like we need to install or import, data cleaning, splitting data into the training, validation and test sets, fitting like any initial model, tuning of like hyper parameters, and evaluation of validation sets. First here, I'm talking about what I'm trying to show here are some of the libraries that I'm going to be using. Like one of it is pandas. Pandas, for it, mostly it's going to be helping us in like reading the document that we are going to be using to generate or like to give instructions to this AI. Yeah, like most of it we are going to be using it to read the CSV document. And then for the NumPy, for it it's going to be helping us like changing some data into the RL form. For the Matplotlib, for it it's going to be helping us with the plot side. Yeah, the plotting of the pie chart that you have seen and the bar chart. For the word cloud, it will be helping us to generate the word cloud. Then the MLTK, for it it's going to be working mostly about like sorting the words, like able to sort the words, know that this word means the same as this other word. So that one we also need it because it will help us in the lemmatization process and also the tokenization process. Then the import and the GINSIM, that one is going to help us in the process of what? Of trying to clean the data. Yeah, when we're trying to clean. Then the GIM as well will also help us in the pre-processing of the what? Of the data that we are going to be using. Then the Scalene matrix and the classification report, that one is going to be helping us like to be able to calculate the accuracy percentage of the model, and also able to identify the training, like to split the data into the training and also the what? The testing. This is like how the Panda will help us, like as in you can see, it's like illustrated with the PDA. So here we have like we put the location of the file that we want to see. I think you can see that it is CSV, because with this CSV it can appear in an Excel form, but it's the one that we can use for the data set to read and for this AI to generate all the plotting that we are going to plot. Here, this process, as you can see it, the code that is here, this code is just helping us to pre-process the data that is going to be auto pre-process the file. So like to remove some things, arrange them so that we like even like also like some stop words like the note, like also in the English, okay, to try to interpret the data that is going to be used. Then this last command, it's like to ask for the output, or it is a command like that enables like to display what is supposed to come out, or the output, okay, generally. This other one, the Scalene, I had talked about it. For it, it's going to help us like splitting the data in a training set, test set, and as you can see the code. Yeah, so these are the files, the number of files where we are seeing the 721, and this is the 5000 is like the total number of files. So it has like already split the data, like 721 are the ones going to be for training, and then for the 7, also this one for 41 is also going to be for the testing, because it has split them into two. There is X1 training shape and then X1 test shape. So they are doing like that. Yeah. Then this one, for this one is going to be talking about the hyperparameters. It has kind of crashed to this slide, but it's going to be talking about the hyperparameters. Hyperparameters. This is like what I can say. It's like getting a point of emphasis, like at which the model should give a lot of concentration, or like should take as in like a first priority. Yeah, in the other parameters. So this is like how it's going to come. And for the model, we are using a naive base, as I'll explain in the other slides that are coming. And then here they've given me a feature warning. Let me say it's a feature warning, like about the numerical the numeric data, I think, because they're like there is some numeric error, and since it's very small, the result will be very small. So I think you can see. For this next one, this one it's also like this is also like also training the model. We are using the naive base, as I talked about it. So here we are like vectorizing. It's also another way like of training, where we are like trying to train it and testing. So here, after like this is the code responsible for it. I won't go much because more details are in the notebook itself, as you can see. Then for the evaluation of accuracy. For the evaluation of accuracy of the models being used, because like according to this model that I'm using, I decided to use the multinomial naive bayes, which is the multinomial and the NB, then the naive bayes, bags of words, where we had the word cloud, and also we have this one, the TF and the IDF vectorization, as we have seen it from the previous slide. Here we are going to be like calculating some of the accuracy of like each model, and then the graph that we are seeing here in the corner is trying to like compare the percentage of like classification, accuracy of the models. Yeah, because mainly why I had to use this, my thing is all about classification, categorizing. I decided to use the naive Bayes classifier, since the naive Bayes is a classifier. So thank you for listening to me, and thank you for watching.